Right, well, welcome everybody. Thank you indeed very much for coming. We realise you have a choice of alternate venues to go to. And I also realise very much that it is Friday afternoon, and even better, it is the last session on Friday afternoon. So I'm desperately hoping that if I don't go on for the full 90 minutes, you'll forgive me gleefully rather than throwing rotten fruit. Okay. This is me. I currently have the privilege of working for Mr. Goodliff at the back at In Music, finding myself for the last 2 years doing an audio application for the first time in my life, at a remarkably advanced age for getting into this sort of thing. Now, before we get started, I just wanted to talk for a moment about what I wanted this session to be about. I'm going to describe the user interface technology we've been using recently. I would absolutely love to show you what we've been using it on, but unfortunately, it's not released yet, so I can't. But I'm going to talk through what it is and how it works, and a fair amount of how it works. But actually, I really wanted this to be a ideas swapping session. How many people here are working on a C++ application with a GUI? Hey. One more, okay. And of those people, how many are doing the GUI directly in C++? Is anybody doing anything else? Right, you guys. Okay. So I'm going to talk about why we're doing this, but I'd also like to hear from you as to why you're doing it and what you're using. Because in particular, I can't approach this session as being 90 minutes of Moses delivering tablets down from the mountain. You will notice that Moses is clutching some particularly elderly tablets in this picture, which is why I want to try and make this a little bit more collaborative, if we possibly can. I also, you'll be very pleased to hear, I'll be very pleased to hear, I have absolutely no intention of trying to teach you everything or even very much about React. Okay? That's just not the time or the place. So we'll be covering it somewhat because I can't escape that. So the plan basically is this. We have to start with, well, what is react-juce? And we can't answer that question without talking a little bit about what JUCE is, and then about what React is. And once we've got those out of the way, we'll go and have a look at react-juce. The next thing I wanted to do was actually take you through, in a wee amount of detail, how it works, what's actually going on inside. And once we've done that, and you're ready to fall asleep or throw things, we'll just move on to a little summary of what the good things have been about this project and what some of the less good things have been. And as we go, I'd really love it if you would tell me your experiences as well. I'm very lucky. This isn't the first project on which I have worked on an application, quite a large application, where the user interface was done in a different language to the main body of the application. I'm very lucky because some of the guys who still work on it are here today, on that application, are here today. So depending on how the timing goes, I might also talk a little bit about that application as well. But The name on the title was react-juce, so we'd better cover something of react-juce before we do anything else. So let's start with JUCE. Well, I have to confess, I was miserably ignorant 2 and a bit years ago. I suspect that JUCE is the most significant C++ library that I'd never heard of before. How many here have heard of JUCE? Yeah, exactly. So I better give you a bit of background. JUCE is the 800-pound gorilla library in the audio industry. It was first released in 2004, so it's been around for quite a while. It's a framework for building audio applications and doing audio plugin development. It's open source, it's C++, and it can be used to target standalone software on Windows, macOS, Linux, iOS, Android, and the various different music plugin forms as well. And when I say Linux, it can do both Linux X11 and Linux desktop. Sorry, Linux X11 and Linux embedded, Linux frame buffer stuff. It's commercial or GPL3 licensed. And here's a little list from the JUCE website of some of the companies that use JUCE. I don't know how well you can read this list, but you know, this is pretty much, I think, a who's who of the audio business. So this is serious. This is a serious piece of software. Just how serious, you can see from the top of the page of the class index inside JUCE. I ignore all the individual class names there. The thing you want to look at here is just simply the number of categories of items that JUCE has got some form of coverage for. And as I've said, GUI and graphics. Yeah, it's got its own graphics library that lets you write traditional desktop-y kind of applications on Windows, on macOS, and on Linux X11, Linux frame buffer. And this is, you know, cross-platform, single-source development stuff here. So I thought we'd take a little look at what JUCE provides you. Because what JUCE provides you in that field is, I would say, it's traditional graphics. The sort of thing that we're very used to seeing in a myriad of different C++ graphical toolboxes. Okay. This particular routine is from one of the JUCE examples, slightly edited. It's a paint routine. Yeah, I'm sure you've all seen 100 things like this before. Pass in a graphics object, fill it with light blue, set a color for stroking fonts, do some stuff with a font, set another color, draw a line. You know, we've seen all this stuff a load of times before. And if you actually run all this code, you get that. So, yeah, it's got it's got a GUI. You can do stuff with it, but maybe there ought to be a better way. So that's JUCE. Next in the pile, React. Okay, React, I must admit, I was hazy about what exactly React was. But anyway, it is an open source front-end JavaScript library for building user interfaces based on components. It's not an application library. React does UI and UI only. Okay. It comes out of Facebook. I should probably call them Meta, but I'm going to keep calling them Facebook for the purposes of this talk, certainly. It was first used in 2011, and its first public release was July 2013. So again, it's been around a while now. Development's hosted on GitHub. I'm going to say that a bit this afternoon. And it's MIT license. And it's JavaScript. Now, I don't know about you, but as an old-time C++, C, Python, whatever developer, JavaScript was a bit terrifying. And it would appear that somebody who looks like Roger Orr also found something very terrifying. If I can divert briefly, this cover is from a Personal Computer World from February 1981. And the lead story in that issue was about a program called The Last One, TLO, which claimed that it would write for you all the computer programs that you ever needed. Hence the headline about, oh my God, is programming about to go obsolete? Well, you know, what goes around comes around, doesn't it? In the 1960s, programmers were going to be obsolete because, hey, we have Fortran and COBOL and anybody can write that. I did notice a tweet from CB of this parish a couple of days ago. He was talking about, is the programmer's job endangered by ChatGPT generating programs for you just when you ask? And he pointed out that his job largely consists at the moment of reviewing code bases written by somebody else, which look terribly plausible and in fact contain hundreds of bugs. He thinks his job's safe for a while. Oh, sorry, they think their job's safe for a while. I'm inclined to agree with them. So, anyway, yeah, nerve myself up. Because, of course, the other thing everybody knows about JavaScript, if you're nowhere near the JavaScript world, is this particular piece of code, an 11-line function that, to left pad strings, that broke an awful lot of stuff when its author pulled it from the NPM JavaScript module repository in 2016. One of the things it broke, incidentally, was React, funnily enough. So, but that's JavaScript. Look at, if you're a curly bracket language person, if you look at it, maybe it's not quite so scary after all. There are some slightly mysterious things. Why do you need 2 equals after that? Well, I mean, basically, JavaScript has essentially got two types of comparison. A slightly dodgy one and a proper one is probably best how I can characterize them briefly. But actually, you know, we're not in too unfamiliar territory here, praise the Lord. Now, during the course of this, I'm going to talk about JavaScript. In fact, we're writing pretty much all our code in Typescript. This is very common in the web world these days. Typescript comes from Microsoft, and it's essentially types bolted onto JavaScript. You pass Typescript through a preprocessor, and you get JavaScript out the other end. JavaScript itself being essentially, I was going to say untyped. That's not quite true, but dynamically typed, shall we say. In particular with JavaScript, if you declare a variable, if you take var I equals -1, if on the next line you say var I equals foo in a string, JavaScript goes, yeah, whatever. Which, of course, for some people can be deeply disturbing. I'm one of those people. So, yeah, okay, come on, React. What are you thinking? Now, what are the reasons behind this? Well, there are reasons, I promise you. And the first one, and for me, probably the major one, React does declarative user interface. Okay. If you're used to writing web pages, if you're used to writing HTML with CSS, you're used to saying, right, can we have a bit of text there, bit of image here, this is all inside a Flexbox container, which is laying stuff out in a vertical column, whatever. You're not mucking around with the details of put this image exactly here. And when the size of things changes, the layout reflows, it's just a kind of rather nicer way for me of doing a user interface. It does have its drawbacks, that's true. But we'll see a bit of React code, some more serious React code later on, and I hope you'll see what I mean. The second reason is simply just compile and link. We have a big C++ code base. And recompile and relink, you know, it's not too bad, but it does take a little while. When you're refining a user interface, you know, you're often going round this cycle of, oh, yeah, can we have that in a slightly different shade of yellow? Can we move that slightly to one side? It's not lining up on the left. If I make this change, will it work now? That sort of thing. If we can get away from a recompile in each of those, that will be a nice thing. And the other reason, and the other thing about react-juce specifically is because we're using JUCE. We don't want to abandon all the JUCE graphics that we've already got, but if we want to move towards a more declarative style of user interface programming, it's there. We should at least give it a go and see how it pans out. And I would note, incidentally, that react-juce is not the first to go in this direction. If you've done Qt programming, you'll have come across QML, which looks to me very much like that goes in the same direction. And there's something else I'm going to talk about in a moment. But anyway, so this is a piece of React code. This is actually the hello world from the React website. Can everybody read that, by the way? That's a big relief, because there's nothing I can do about this one if you can't. Now, the story of what's going on here is essentially we're creating, there is incidentally a tiny little bit of HTML boilerplate that I haven't bothered including in here. But essentially what we're doing is creating a root window, whatever, and rendering stuff onto it. And what we're rendering onto it, we're rendering by executing code. I know up here, it doesn't look like, and indeed and there, that doesn't look like code. But actually it is. So my next little diversion is into something called JSX, which is JavaScript something XML. Essentially what's going on here is these two pieces of code are the same. Okay? This bottom one is the actual JavaScript code you're executing. All right? JSX is essentially a bit of syntactic sugar that lets you write something that looks, in this case, like HTML, which is so you can see what you're dealing with, basically. You can see the HTML wood for the trees, and JSX transforms it into what you actually should have written. There's a video on YouTube of one of the React team from some years ago now, shortly after React came out, discussing this, because they got a lot of feedback with people going, "Oh, you're mixing presentation and business logic here. You shouldn't be doing that." His response to that was essentially, "No, we're not." And anyway, because React focuses on components, you're implementing components, and the appearance is part of that implementation. So, the other thing that you do with components is pass properties into them. Now, properties are a JavaScript dictionary, a JavaScript object. JavaScript objects are kind of things like Python dictionaries. Okay. And in particular, JSX also lets you substitute dictionary elements, or in fact, any bit of valid JavaScript in between the curly braces here. So you can, as you can see here, the effect of this is to return hello, comma, there. From here, you're passing, you are effectively passing a parameter into the code that is generating your greeting component. And one important thing here is that when any of those property values change, React will re-render the component and everything underneath it, all its children as well. Components can also have state. Now, at this point, I need to put a little pause in. React originally, the way you specified components was as a class, a classic class inheriting from a React component and overriding various methods and so forth. In recent years, they've been moving to a much more functional style of usage. These examples are in the functional style. You will later on see a bit of code which is more old school, class-like. React has the concept of state for a component, and what's happening here is this React method useState is creating a state with an initial value of red, and it's returning two items. The first one will retrieve the current value. Those are two functions. The first one will retrieve the current value of that state item, and the second one lets you update that state item. And so what's happening here, okay, this is a little React component that will return my favorite color is red, show you a button, and when you click on the button, it'll change red to blue in what it's showing you. This bit of syntax here is actually declaring, it's basically declaring a lambda here. So this is saying pass to onClick, which you can probably guess what that does. Pass to onClick a function which, when it's executed, when you click on the button, will change the state to blue. Now, as with properties, anytime you change state in React, it will re-render that component and all children of that component by running the component function. If it's defined in a functional way, it runs the component function and picks up the result from that function. If it's a class, there's a method called render, which basically does the same thing. Now, this is all this is why it's called React. It's reactive. You change properties, you change the state, your display will update. Which is, yeah, all very hunky-dory, really. But hang on, doesn't that mean that every time you change anything, an awful lot of your GUI goes and updates itself? Because it sounds like it's all getting even worse. The return from each of these functions is giving you a new version of the component. Do you really want all your UI components trashed and rebuilt every time the display changes? Because if you do, what about, I mean, it'd be horribly expensive anyway. And suppose one of those components was a text input and the user was halfway through doing an input. This is just not a terribly good idea. So what React actually does is what it deals with is a virtual representation of your component hierarchy. So components, as we've seen, they have state and they have properties. It generates the hierarchy of components with properties and state in there each time. But when it's generated that whole display, which if you're talking about traditional React targeted at a web browser is React DOM, okay, that virtual DOM is then fed to a React process called the reconciler. And what the reconciler does is try to work out the minimal set of updates to the real display. So these things are components which are real web DOM components. So React tries to work out, when I say tries, it's because I think it's a problem that is, theoretically impossible to do perfectly, but actually a good set of heuristics gets you pretty much where you want to be. So typically in this case, typically as you can see, what happens is you're regenerating the whole virtual DOM, and then probably what's happening is you're updating a couple of properties on a couple of components within the DOM. You're not doing a whole redraw of everything. Now, I'm going to talk a bit more about the reconciler later, so we'll be coming back to this. I just mentioned DOM. And in particular, you'll have noticed on the first example, we're importing React from the React module. And then we're importing React DOM from something called React DOM/client. React DOM, basically, as I said, it means that React backend that targets web browsers. It's the original React. But these days, there are other sorts of React backends. And the big one I need to mention here is React Native. It's a framework for writing a UI in platform native components. Again, it comes out of Facebook. It's used by them and others, including Microsoft, for delivering Android and iOS. Those are the two really big uses of React Native. Android and iOS apps for your phone. If you're using, say, the Facebook app on your phone or Insta or whatever, it's React Native that's behind that. There are also other backends. I'm not going to try and cover all of them. But interestingly, there appear to be, I haven't tried these out myself, but there appear to be sort of backends for the Mac desktop and for the Universal Windows platform. But there's even actually a backend that apparently targets web browsers. I haven't quite worked out why this makes sense, but it's interesting. Here's an example of some React native code. There's a bit more code here than we saw in the Hello World example. But I hope you can see it's pretty much the same sort of thing happening. We just have a bunch of components in a parent-child hierarchy, components that have properties. One of those properties in this case is a property called style. And in React Native doesn't, what we have to realize here is these are native OS user interface components. There is no HTML going on here. There is no HTML engine, and in particular, there is no CSS either. So while you can pass styles that look CSS-oid in, and they're a very nice way of seeing how your object is styled, there isn't CSS happening. There's no styles being inherited or whatever. It's the danger here. I'm not going to talk any more about React Native at this point, but just stress again, this bit here, importing React. React Native uses the same core engine as React DOM, and it's this core engine that is running through the generation process, calling the reconciler, and so on. Right, finally, I think it's time to get round to react-juce. Now, react-juce, I would really characterize as a kind of riff on React Native. It is not a React Native backend. It's intended for use with JUCE and using JUCE components. The React Native has a large list of available components. It'd be a fair amount of work to try and implement all of those in JUCE, and it's not the aim of, it wasn't the aim of the project. React-juce, it was originally released in 2019 by a guy called Nick Thompson under the name Blueprint. Nick has moved on to other more interesting things. He's now really interested in doing audio in JavaScript. Again, the development is hosted on GitHub and it's MIT licensed. It's been passed now to another maintainer, a guy called Josh Marler, who was working for InMusic at the time when I joined them, but fortunately has since departed for pastures new. But it uses the same kind of idea as React Native, driving native components, in this case JUCE components, from the React engine. It has a rather restricted list. It's very young, and it has a rather restricted list of available components. This is the entire list of things you can do on a UI. That being said, we have managed to achieve nearly everything we wanted to achieve with these components. So I'm not going to whinge too heavily. It's reasonably obvious what most of them do, but I should just explain. View is just the wrapper component, I guess. It would kind of be equivalent to, say, a div in HTML. Typically, when you're writing a component, in fact, invariably, when you're writing a component, one thing in React is when you return a component, it's always a single thing, which may include children. Okay, so in the case of React-juce, almost invariably what you're getting back is a view which will have one or two other components inside. Of course, possibly you just want a very simple button and the button component is perfectly adequate, and in that case you just get back a plain old button. A scroll view is just a generic scrolling scroll bar with a scrollable viewport attached to it. A list view builds on that to present you with a scrollable list of things. react-juce is a long way from being anywhere near what you might think of as mature. The best illustration I can give you of this is currently in a list view, you can only have a vertically scrolling list. You can't have a horizontally scrolling list, which is really a bit pants, but luckily we haven't really required a horizontally scrolling list. At least we didn't right up until the moment when we did. Anyway, but react-juce in its public form at the moment only contains a scrolling vertical list. react-juce uses a couple of the same components as React Native. The number one of these is Hermes. Hermes is a JavaScript. If you're going to execute React, you've got to have a JavaScript engine. The JavaScript engine we're using is Hermes. react-juce was actually originally written for another JavaScript engine called duct tape. Hermes has emerged since from Facebook, and and at some point last year, Hermes became the JavaScript engine, the default JavaScript engine for React Native. Okay. Hermes, it was designed for use on mobile devices. The project I'm working on is targeting an embedded device, so it's a good fit for us in that respect. And it was designed specifically both for mobile devices and for fast startup. If you've ever written, certainly an Android application, you'll know that when you're switching to and from, you can actually be starting that application all over again. So fast startup is important. The other thing you have to know about Hermes is that Hermes compiles to a bytecode. There is an external compiler. You can either compile the bytecode yourself for even faster startup, or you can give it textual JavaScript and it will do the compilation. It compiles to a byte script, but it then interprets the byte script. It does not JIT to native code. There are reasons for this. One of them, I think, is keeping the memory footprint small, although 20 years ago, I was working on a Java virtual machine targeted at embedded devices, and that didn't need a very big memory footprint. A bigger reason is probably, in my mind, that Apple does not permit, in the App Store, it does not permit applications which generate something and then try and jump to that. They class it as a security hole, a potential security hole. I'm slightly suspicious myself of this attitude. But on the other hand, I think it was probably the same mindset that kept Flash off iOS. And I think that's something we can all be deeply grateful for. So that's one piece of React Native that is used by react-juce. The other major component of React Native that's used by react-juce is, again, it comes out of Facebook, it's on GitHub, it's MIT licensed, and it's a layout engine called Yoga. And Yoga implements basically the HTML flexbox layout system. So when I say remember in React Native and in react-juce, you don't have an HTML engine and you don't have CSS. You don't, but you do actually have the layout part of HTML, modern HTML. So that's enough whiffling about the background. We probably ought to try and see it in action at this point. Now, again, as an extremely immature project, I'm slightly handicapped here in that there is only one example app for react-juce. Again, I'd love to show you what I'm working on, but that can't be done. So that did at least make my decision easy about what to show you. Here we go. This is everything you see on that UI is React and JavaScript. But there's a C++ application running behind it. If I try and move my mouse onto it and unmute it, this is just a simple gain control. Okay? Unfortunately, on my laptop, the only input I have is the microphone, and the only output I've got is the speaker. So the minute I unmute this, there's going to be a feedback howl. But with a bit of luck, you should see these bars flashing. So there, that's all in React. So, first question is, yeah, okay, it's got a fairly simple layout on the front page, if you can remember it. We have an image. This is actually a sort of slider, I think. This is a control that's being drawn. This thing is just sort of moving across at a timer to let you know it's alive, and then finally there's a button. But let's go and have a look and see what the code looks like. Now, it's at this point I am going to try and jump off to an editor, and this is almost certainly where everything is going to go a little bit fumbly, but bear with me. Here we go. This is the React code for what you've just seen. So there was the logo source. The whole thing is wrapped in a view. With container styles applied to it. It probably wasn't entirely necessary in this case, but there you go. So we have our main view here. Now, what you can't see at the bottom is the styles. So I'll see if I can scroll that down a little way. You see the content style here has got flex direction, justify content, align items, padding, max width, and aspect ratio. One thing about React is because it's JavaScript and it's not CSS, instead of using, CSS uses max-width, all lowercase. React makes all properties into camel case. I had a good name for that, the CSS thing. Was it called, not camel case, but pipe case or something like that, I think. Anyway, so if you're at all familiar with doing layout in HTML, you'll recognize that kind of approach. If I go back up to where we were, here we go, and you'll see that's why we have an image above a knob, above a meter, above a canvas. A canvas is just a control you can draw into. And then at the bottom, we have the button, and which itself wraps a bit of text. So yeah, this is probably all stuff that is reasonably comprehensible, I think. You look at that and think, yeah, I can get the hang of this. I thought we'd have a quick look at some of the things on the way, in particular the meter, because as I said, the meter itself is drawn on a canvas. So if we go and look at, where's meter gone? There it is. If we have a look at meter, you see meter has a state. This is a component written in old school React class style. Okay. These two things here are a bit of magic, which I still haven't quite got my head around, but necessary to bind on measure and on meter values to this function, and there's a one below it at the bottom. In class React, the way you update a state is you call a method called this.setState to update your state. You don't assign to it directly. Okay, so the state is storing the width and height of the meter and the left and the right peaks to display. Mount and unmount are called when the control is created and when the control's removed from the screen. And let's dash down a little bit. I'm going to digress briefly. If in JavaScript level, you need to know what the size of your component is, in react-juce, the way you do this is react-juce, when the size of anything changes at the juice level, it fires off a method called onMeasure with the new dimensions in it. We may actually see that in a bit later, or you may get thoroughly sick of watching code at that point. Down here, this render vector graphics, you can see it's generating an SVG and just returning that. So the rendering process just consists of breaking the peak and the width and height out of the current state and returning a view. That's hooking up the onMeasure routine to the view with an image inside the view where the source of the image is that SVG that we're generating. And that's how it works. That's it. But we've got this question about the values that we were looking at, the gain values, like where the heck are they coming from? This LC peak and RC peak. Let's go and find where they get set. Here we go. There's this on meter values callback being triggered, which is updating them, see, in the state. So because it's being the state is being updated there, that is triggering a refresh. So, yeah. Those values are coming from C++ land. And at this point, we're going to go dive off and have a look at the sole C++ module in all this, which is, where is it? Plug-in processor. Now, this example program, it uses a JUCE class audio processor, which basically handles setting up a lot of your app for a plugin. And as part of that, it will generate what we've just seen, which is a standalone wrapper for that plugin. Okay. Somewhere down here, sorry, that's the .h. In the CPP, let's go find it. Where are we? It's down near the bottom somewhere. There we go. Not quite. Here we go. part of that standard JUCE class is there's a way of, you can give it what it calls a generic editor. The comment explains what the generic editor is all about. And the interesting thing about this function is this is where all the magic, this is where the JavaScript magic starts to happen. Okay? We're getting a file which is a JavaScript bundle. So that's basically there's a program called Webpack has processed all your individual JavaScript files and spat out one horrendous JavaScript file you should never, ever attempt to look at. Okay, and we're passing that bundle into react-juce helpfully provides a generic editor implementation for us. Okay, you can see what's happening there, just setting an initial size, starting a timer to update those gain values. Okay, so here's the timer call. So this timer starts running. This timer will now get called every 100 milliseconds. And it is dispatching an event called gain peak values into this thing called React app root. And it's giving it 2 float arguments, which means we probably now will first of all go and have a look at that React generic editor thing to see what on earth was going on there. And over here somewhere we have React. This is the react-juce generic editor implementation. The important things here in the class, there's a few vital components in here. An ECMAScript engine. ECMAScript, you almost certainly know, is JavaScript, well, standardized JavaScript is officially ECMAScript. Anyway, there's this React application root object which holds everything together. And there's also this app harness thing that we'll take a look at in a moment. And the bundle file. And the bundle file is, okay, what JavaScript are you going to be executing then? So over in the implementation, where are we? There's some more, yeah, here we go. Before we get confused here, as you can see, the editor component is setting a size and fully expecting to be overridden, which it almost immediately will be by the outside window. What are we looking at? There we go. So we're taking the bundle file. Okay, there's a bit of mucking around with some parameters, which I don't really want to go into at this point. And this is the interesting bit. The app harness inside react-juce essentially takes care of looking at the bundle file and getting it executed. And you'll notice here we have if we're in debug build, we're going to start the harness, but otherwise we're only going to execute it once. Add and make visible here is a JUCE method which does exactly what it says on the tin. Okay. This has its own timer because it's got this particular component also has stuff it reports, but I don't really want to distract us by going into that at the moment. The interesting thing here is, okay, what is harness start doing and what's harness once doing? So, and over here, we will have a quick look inside app harness. Where have they gone? App harness. Yeah, it provides file watching and hot reloading. It's the hot reloading I'm interested in here. It's down here. There's some stuff setting up watches on files. You'll notice that it distinguishes between files that contain textual JavaScript and files with bytecode, because you need to do slightly different things with them. Here's the start implementation. And essentially what's going on here is handle files changed, which you can tell, you'll see down here in the implementation of just once. Handle files changed is the method that does the magic here. With the file watcher, essentially what it's doing is whenever it sees a file it's watching changing, it recalls that thing. So handle files changed is the interesting bit here. And what that does, it's actually quite simple. It's less worrying than you might fear. It does a little bit of mucking around with the application root, but the guts of it down here are asking the app root to evaluate the file. Now, I'm kind of conscious that I could go on for quite a long time digging down into this, but essentially, I might skip a bit and just say, what this is doing is you finally get around to a point where you know that engine object you've got, it executes that JavaScript. So you hit that point, the JavaScript engine starts up, it does the first run through, sets up all the components, renders everything because it's starting from scratch. Okay? Once it's done that, it'll fall off the bottom and return here. And at that point, the JUCE event loop will take over. And when events happen, those events will be picked up by the native components, turned into events to be delivered into JavaScript. JavaScript will pick those up and pass those on to the React component, so you deal with these events as if they had happened purely in JavaScript. So you're dealing with this stuff from JavaScript. I did come here prepared to take you through the whole ghastly thing, but I'm conscious that I've now been wittering for an hour, and most of you are probably close to slitting something. So I'm very, very happy to take anybody who's interested through the rest of this, okay? Because actually, once you look at it, I don't know, in the past when I've approached frameworks like this, it always feels like you do this and then magic happens. And I wanted to try and show you that actually magic isn't happening here. It is comprehensible. The one other, so, diving a bit further. So we'll skip looking deeply into the engine. Particularly, I'll spare you the details of the interface into Hermes. The one thing that's interesting there is that the thing that has to happen when you're going in and out of Hermes, Hermes, of course, has its own representation for a JavaScript thing. In this framework, when you're calling the engine or receiving results from the engine, the arguments are fed in as, JUCE has a variant type of its own. The arguments are all fed in and returned as JUCE vars. You have to bear in mind JUCE has been around for a long time, so it predates quite a lot of the standard library stuff that we have now in C++. So everything has to be translated to and from a JUCE var into a Hermes representation object, which sounds like it might be a horrendous overhead. In fact, actually, I haven't found it to be so yet. Because one of the things that I am going to talk about is, yeah, let's spare you all this stuff. I can talk about how the components work. Do you know, I turned up here thinking I was going to run through all this content in about 20 minutes and we're all going to sit around looking very embarrassed. But anyway, the other thing, but the one final thing I wanted to show you briefly was the React reconciler backend, the bit that actually does the magic of hooking the React reconciler up to JavaScript. Now, where is it? There's a lot of stuff around here. Methods, there we go. It's this thing, renderer. Because actually, it's very simple. I just briefly scroll through so you can have a look and assess its complexity. But the important thing here is these two methods. Because the React reconciler needs a way to know whether a DOM object differs from the actual object that is on the display, and then another method to apply a change if it turns out there's a change. And the reason I'm showing you this is, no, I'm going to come back to it. The reason I'm showing you that is because I am going to talk briefly about performance. And that's one place where we have found interesting performance. We have found a performance issue, somewhat. The other thing I was going to briefly say was that what I've shown you so far is sending data into React by sending custom events. That's a bit tedious. React in the field is almost invariably used with some sort of state manager. And all the hip cool cats these days are using a state manager called MobX. I'm just very briefly going to talk about MobX. In their own words, it is a simple, scalable state management library which prevents inconsistent state by ensuring all derivations are performed automatically. So it has this concept of derived or calculated values. Calculated ones are calculated off existing values. Derived ones, you have to go and call something to find out what they are. But it will make sure that they get called at the right times, so your state is always consistent. And it's used in React combined with, well, for us certainly, MobX React-like, something that hooks MobX into React. So rather than relying on the state updates to the state inside React, the crucial thing here is this piece of magic here, which is a MobX thing, which will observe that value, and anytime that value changes, it will tell React, and React will update. Okay, it makes it really quite easy to have a display that is always consistent with your data. It also makes it really quite easy to achieve this by refreshing the display far too many times. But that's the story. That is a story for an entire other talk. My dear colleague Nacho can tell you far more about it than I can. But the good thing about this, and the way we're using it, is that with MobX, you can send changes of state into MobX by sending it JSON. So you can send a lot of changes, describing changes to your state by altering paths in your state hierarchy. So you only need one, in fact, we have two events to transmit to React. We have one event that says just apply this patch. Okay, you can have add, replace, or remove operators in that. The other one we've got is actually just, here's the entire tree again. The change has just got too big. It doesn't make sense to try and delta this thing. Look, wipe what you've got, and use this state from scratch. Anyway, having got to that point, I think really I should start talking about what we like about react-juce. Well, the first thing we like about react-juce is JUCE. It works with JUCE. It lets us do UI in a different way, in a declarative way with JUCE. As I said, we have a big JUCE code base. This is very useful stuff to us. One thing I should have mentioned incidentally but didn't was that, or should have emphasized but didn't, is that if you do have a component which has graphics that really needs to change very quickly with minimal processor load, it's perfectly possible to implement that in C++ and just have it as an item in your JUCE, a component in your JUCE hierarchy, in your react-juce hierarchy, I beg your pardon. So you've got flexibility. You don't have to do everything in React if it suits you to do it another way. It lets us build UIs declaratively with a flexbox layout. And that actually is a nice thing to do. I said it lets us use native code JUCE components. And the other great thing that it does in debug, you remember we looked through that harness where there was a thing about debug and doing, if you're in a debug build, have a file watcher. What that means, and I can demonstrate this if anybody wants on the demo, you can change your JavaScript, save it in your editor, there will be a brief pause and your display will update with the new JavaScript. If you change a color, you can see the color change in a second. If you change the layout, you can see the change in a second. This means that if you are needing to modify your UI, it can be a very quick thing to do compared to repeatedly having to go around a traditional compile and link cycle. Now, there are things we like less about react-juce. And I think for me, for this C++ programmer, the first thing that I wasn't quite so keen on was having to get up to speed on JavaScript. It's a hurdle. And when you've got some kind of idea of what's going on with JavaScript, of course, you also have to get up to speed on TypeScript as well. And when you've done that, you've got to get up to speed with React. And in our case, when you've done that, you've got to get up to speed with MobX. You know, there is a bit of a hill here. So it takes you time to climb that hill. Now, as you probably know, I have spent a lot of this conference selling off a small part of the library of my late friend Hubert Matthews. And I once had a conversation when I was starting the project I alluded to with my colleagues here, where we were replacing a proprietary, horrible UI, wildly outdated system with Python and Qt. I talked to Hubert about this project. Now, Hubert consulted widely with some very blue chip companies and some very small companies. And he once told me that in his experience, if you introduce a new language or a new significant framework to a project, you should add 18 months onto that project. This stuff takes time. It takes time to learn how to do it well. Okay, so time. I mentioned just now speed. As I said, we're running on an embedded system, and of course, although Hermes has got lots of clever tricks in it, it is at the end of the day interpreting. That little bit of reconciler code that I showed you, where it's going through and finding out whether any of the properties in a component have changed. I mean, literally all it's doing is going, hey, property value X equals Y here. What does it equal on this other component here? Usually that doesn't take very long. But if you have a vertical list and each element on the list, the display on that has got 10 or 20 subcomponents in it, you can find yourself dealing with quite a lot of components on the screen at one go, which is one reason why you have to be very, very careful about making sure you are not updating things unnecessarily. Because I had a period of time where we were wondering why our display wasn't refreshing quite as quickly as we'd like. And doing timing, it just looked like we were going into a render and 200 milliseconds was passing for no readily apparent reason. And actually, when we dug in, it was all spinning round, that little bit of the reconciler. I've talked to a couple of people who have done React development properly. I wouldn't call myself a serious React developer, but React web developers. And when I've asked them about React performance, they've actually generally coughed and shuffled a little bit and said, well, actually, you know, the React community, they're not really terribly focused on performance. And from my point of view, I think this makes some kind of sense, because actually when you're dealing with React in the web, and that is the bulk of React, you're typically dealing with a situation where you've got a user interface in your browser, and you're talking to a database that's probably 2,000 kilometers away. Are you really going to sweat 10, 20 milliseconds updating your display? It's probably not where the community's head is at. So I kind of really have to forgive them this one. And the final item of some regret about React-Juice is that since starting the project I'm working on, remember React-Juice itself only started in 2019, as an open source project, the tide has somewhat gone out. In the early days, certainly React-Juice attracted commits from some notable names, in particularly Mr. Juice himself, the founder of JUCE. But there hasn't been a great deal of activity for a year or so now. And which means that, well, who knows, are we the only people doing something sizable? You know, and actually, we have changes we want to contribute back. But the guy who is the official maintainer at the moment, I know has a young child. There's only one of him. We have a product to get out the door. So hopefully in time, we would like to see React-Juice at least updated with the changes we've made for it. But I can't predict the future. Let's hope so. Let's hope that it gets a maintainer, it gets some time, somebody who can devote time to it, and so forth. But it would be much nicer if this was a thriving project. But I suspect you have probably had similar experiences in the past. It's kind of the nature of software, isn't it?